So the question that becomes now is it possible to relate an atom's electron configuration to its position in the periodic table, and also relate it to the observation that elements that are in the same group have similar reactivity? So what we're going to do is we're going to look at a bunch of elements that are in group 1. So if you look at these group 1A elements, there's some interesting trends here. The first thing that you'll see is that the highest shell in every case corresponds to the period number. So lithium's in period 2, francium's in period 7, and that follows all the way through. So something that's happening is every time we go down a row in the periodic table, as we head down 1, 2, 3, 4, 5, 6, 7, we seem to be adding another shell or another layer of electrons. So that's what the periods correspond to, is the beginning of another layer of electrons. The other thing that's interesting about these group 1A elements is that they all have an electron configuration that ends with S1. That is, that the outermost electron, that one that's on the surface of the atom that other atoms will detect, is in the same type of orbital. They'll all have as their last electron an electron that is in a singularly occupied S subshell. So considering that the outside of all these atoms looks similar, it's not surprising that all of the elements in group 1A are chemically similar in their properties. And if you look at other groups, you see the same thing. So this is group 5A, and what we see here is that these guys all end in P3, right? They all end in P3, and again you see that the highest shell corresponds to the period of the element. So that's kind of cool. And what you also see is if you add together the sum of electrons that are in the outermost shell, sometimes it gets broken up by some d electrons, it always adds up in each case to 5 every time. Now for these elements, they're all in group 5A. So what we're seeing is that the total number of electrons in the outermost shell equals the group number. And it's found that for the representative elements, those that are in the A groups, this is always the case. So the number of outer electrons is always equal to the group number for the elements that are in the representative elements. Okay, so elements in the same group have similar chemical properties because they have similar, or identical in fact, arrangements of their outer electrons. An element's period number identifies its highest shell. That means every time we move down a row in the periodic table, we're adding another layer of electrons. Now, the total number of electrons in the highest shell for a representative element, that is just equal to the group number. So we don't need to write out the electron configuration to get that.